Okay, so for this particular task in chemistry, you are asked to solve for the average atomic mass of the mixtures of isotopes. Mixtures of isotopes, meaning an element which has more than one form. We call them isotopes. So let's go over first what are isotopes the way we learned it in the previous days. So the concept of the isotopes are, they are the same elements, but the elements have different mass. Same element, but different mass. And the cause why your elements have the same mass, or your isotopes have different mass, it's because of the number of neutrally charged neutrons. So the different mass is due to the different number of neutrons. Okay? So if you're gonna look at our first example here, our first item, we have Au and Au. So same element because the symbol is the same. Au, the name for that element is gold. And you're given two items for Au. We have 50% Au-197 and 50% Au-198. So two given, meaning Au has two isotopes. Same element, but if you look at the number after the element, 197 and 198, that's the mass number. And so they have different mass. Remember that the dash that you see is not a negative number. It just separates the symbol from the mass number. So Au-197 and Au-198. So before we proceed to the calculation of the average atomic mass of this Au's isotopes, let's label them, okay? Let me label it, and please do the same on your notes so you won't forget. The two numbers that you see after the dash represent the mass number. Okay? So I'm labeling it so that you will know when I use these numbers, you will know where it's coming from. Okay? So those numbers without the dash, positive numbers, are the mass numbers. Okay? The next one I'm going to encircle is the percentage. Okay? Percentage. And I will put that here. The label for the percentage is, they are called the percent abundance. The percent abundance of the element is like a percentage of how popular the element of that isotope is. Like how popular, like how many there are. The higher the percentage, the more abundant the isotope is. But in this case of the given, you have 50 and a 50. So they're just balanced. The two isotopes are balanced. Okay? So percent abundance is just how abundant that particular isotope is in our planet. Now, do we have any questions with the labels of what they mean? Percent abundance for the percentage, and the number after the symbol is the mass number. Now, after labeling this, we are ready to solve for the average atomic mass of all the isotopes of your given. So let's start with putting in our given first. I want to write down my given in place here. I just want to copy it. Okay, let me copy it. So I have, let me use a black pen. I have 50%, so I copy the first one. It's 50% Au-197. So I'm copying only. I'm copying. I'm not yet solving. And the second given is another 50% Au-198. Why am I copying it? Because I want to make them vertical. So you will see the step-by-step process, okay? So I copied the second one. So they're all in place now. So let's begin with our step 1. Step 1 is focusing on the percentage. So let me box that, okay? So focus on the percentage first. So what do we do with the percentage? So step 1 for the percentage is, step 1, divide by 100. As always, you cannot use the percentage as is. You need to make it in a decimal format. And so to make a decimal format of all percentages, you know that you need to divide them by 100. So let me show you how to do that. So let me put an equal sign here. I'm going to transform my 50% into a decimal. So that's going to be 50 divided by 100. Same thing with this. It's also 50 divided by 100. Okay? Then I go to the calculator. So 50 divided by 100 is 0.50, which is the same here because it's the same number. So that's 0.50 as well. So that's the first step result. Do we have any questions with step 1? So I don't hear any questions. So let me just put an arrow that this is now my new output for my step 1. My 50 and 50% became 0.50 and 0.50. Now I'm going to go ahead to step 2. Where do we focus for step 2? For step 2, we need to focus now on the mass number. So let me box the mass number here. My mass numbers are 197 and 198. What do I do with them? I am going to multiply them to my new percentage in decimal. So I'm going to put 197 to 0.5 and I'm going to multiply it. So I'm going to put a parenthesis and put the 197 here. And then the 198 parenthesis, which means multiply, times 198. So I'm going to put that there. So this is my step 2. Multiply by the mass number. Where did I get the mass number? Again, I get it from the given. Then, once I put all the numbers to be multiplied, I put an equal sign, and I go to my calculator, and I do the multiplication there. So the first one is 0.5 times, or 0.50 times 197, and the product is 98.5. The second one is 0.50 times 198, that's equal to 99. Again, parenthesis means multiplication, so readily use the multiplication function in your calculator and you will get these answers. Okay? So that will be the answer to your step 2. That's your step 2 right there. And once we're done with step 2, we are now going to the last step. How do I combine the two products here? All you need to do is add them. And that is step 3. So step 3 is add the products. So let me show you how to add that. So I'm just going to rewrite them. So that's 98.5 plus 99. Okay? And then go to the calculator, or you can even do that manually. 98.5 plus 99. You will get 197.5 0.5 as your final answer. And the unit for the average atomic mass is the unit AMU. This is a new unit that we're learning. And what does AMU mean? You may put it in your notes. AMU is just a shortcut, but the actual meaning of AMU means atomic mass unit. So AMU for short. So go ahead and look at the entire process as you see here. Let me zoom it in. So that's the entire step. From step 1, divide by 100. After dividing by 100, you will multiply them, step 2, by the given mass numbers, just the given. Then multiply them in the calculator so that you can go ahead to step 3, add all the products to get the final answer.